Today came here with the second part of the video of the polynuclear hydrocarbon. We will today concentrate on the two products, that is the anthracene and phenanthrene. These are two products. We will see the possible reactions, the preparation and the corresponding resonating structure, which we discussed in the last part of the video. Now you can see the anthracene. We have seen here the numbering system of the anthracene, which will start from the left, and the corresponding 10 up to 10 it will goes, and the corresponding the resonating structure we have focused earlier, that is the n+1 resonating structure. If it is in a straight chain of any polynuclear hydrocarbon will provide, as the n is a number of the benzene ring. Now we can see the phenanthrene here. There is an angular polynuclear hydrocarbon which will show the resonating structure in the different pattern, as will not follow the principle as of n+1 rule, as it has the angular pattern of the polynuclear hydrocarbon. Now we can focus over the synthesis. Let's take the ERP synthesis. The conversion of diaryl ketone containing a methyl or methylene group orthoposition to the carbonyl functional is known as an ERP reaction. When orthomethyl benzophenone is heated at 450 degrees centigrade, anthracene is formed. Very importantly, the temperature is must be taken into note, that is, it should be 450 degrees centigrade and around it, and it will give the release of water to produce the anthracene molecule. Now we'll see the Friedel-Crafts reaction. Benzyl chloride react with ethyl to form the 9,10 dihydroanthracene, which readily reduces 2 hydrogen to yields anthracene. Benzyl chloride, when react with benzyl chloride in the presence of the LCl, the aluminum chloride, it will release the 2 HCl molecule with the formation of the 9,10 dihydroanthracene, and the corresponding rearrangement it will form the anthracene. Now we see the Das-Elder reaction, which will starting material is the naphthoquinone and 1,3-butadiene, and the corresponding oxidation and with reaction with zinc, it will produce our final product of anthracene. The Howard synthesis of anthracene, that is a benzene, when getting react with phthalic anhydride in the presence of AlCl3, it will form 2 benzoyl benzic acid. In the presence of sulfuric acid, it will formation of 9,10 dione, this is 2 ketone will form, and corresponding reaction with the zinc in presence of mercury and SO, it will reduce it to produce a 9,10 dihydroanthracene, and the corresponding it will forms the anthracene molecule. It is the Howard, the most important one, and the Howard synthesis of phenanthrene, which is the only part which will focus, that is an naphthalene when reacted with succidic anhydride, and the corresponding oxopentatonic acid has been formed, and the corresponding reaction with a sulfuric acid and zinc, it will produce again the phenanthrene. The procedure is almost very similar to that of the anthracene. Now we will see the reaction. The first is the oxidation. Here to Cr2O7, it will produce 9,10 anthraquinone or 9,10 pentathrone. Now we will see the reduction in the presence of the sodium, heat and ethyl alcohol and PEOH. It will produce 2 substances. One is a 9,10 dihydroanthracene and 9,10 dihydrophenanthrene. There is a 2 part for the 2 things. The electrophilic substitution reaction of anthracene, it will produce the 9 position and 1 position. We can see that is 1 anthracenic acid, sulfonic acid. It will react with sulfuric acid. It will react with chlorine in CCl4. It will form chloro. If we react with nitric acid, then nitro. If we react with CH3COCl, then it will forms an acetyl group. Same reaction which will follow with that of the phenanthrene. We can see the same chemical reagent we have been used to form the substituted products, which will give here. And the last and foremost, we have given here the overall chart mechanism, the chart reaction of the anthracene and the chart reaction of phenanthrene. Thank you.